In this last bit of research, we focused on looking at the climatic effects of very large volcanic eruptions over the interval of time from 30 to 80,000 years, which very broadly coincides with the last glacial maximum. And we looked specifically at how these very large eruptions affect climate in the opposite hemisphere from the eruption. So we used previously published paleoclimate records from Greenland, Antarctica, reconstructing temperature in those locations, as well as low latitude records from stalagmites to reconstruct rainfall at low latitudes. And what we found was that the hemisphere of the eruption is very important in determining the climatic response. Very large volcanic eruptions are thought in general to have a cooling effect on the Earth's climate. What our research shows is that the truth is actually a little bit more complicated than that. The hemisphere of the eruption is very important. The volcanic eruption injects sulfate particles into the stratosphere, which reflect solar radiation. So a northern hemisphere volcanic eruption cools the northern hemisphere preferentially and moves weather patterns to the south. So for example, following the northern hemisphere Toba super eruption at 74,000 years before present, the northern hemisphere cooled, Greenland cooled, low latitude rain belts moved to the south, but Antarctica warmed. And this is a result which is maybe a little counterintuitive. To work out how a large volcanic eruption could affect climate, we have to look to the past. What our research uses is published ice core and stalagmite records from the interval 30 to 80,000 years before present, and it works out what the climatic response was to these volcanic eruptions. And we can use this information as a template to try to work out what might happen in the future. So although baseline conditions are very different now than they were during the last glacial maximum, for example, we don't have large northern hemisphere ice sheets, we can still use this information to help work out what might happen. Since the Industrial Revolution, there's been sulfate emissions and there's been man-made greenhouse gas emissions. And we have to consider the reality that a large volcanic eruption taking place under these new modern conditions could have very unpredictable consequences for climate. The next steps in the research would be to better understand southern hemisphere eruptions and how they affect climate. There's no reason why the number of known southern hemisphere eruptions should be less than the number of known northern hemisphere eruptions, but we know of very, very few southern hemisphere eruptions. So the next step would be to identify and date these eruptions so we can work out exactly what the effect of these southern hemisphere eruptions might have been on global climate and particularly climate in Greenland.